Kia ora and welcome to the February Jodcast from Space Place at Carter Observatory in Wellington, New Zealand. The month begins with a total lunar eclipse, when the moon moves completely into the Earth's shadow. Whilst the penumbral phase starts shortly before midnight on the night of January the 31st, totality begins at 1:51 a.m. on the morning of the 1st of February and lasts until shortly after 3 a.m. Unlike a solar eclipse, which is only visible from a very specific path along the Earth's surface, a lunar eclipse is visible from anywhere on the night side of the planet. Whilst the Earth blocks all direct light from the Sun, some light passes through the Earth's atmosphere and is bent or refracted towards the surface of the Moon. Light with shorter wavelengths towards the blue end of the spectrum is scattered more strongly, so only the redder light gets through, giving the eclipsed Moon a telltale reddish glow. Whilst New Zealand won't see it, some parts of the southern hemisphere will also experience a partial solar eclipse this month on the morning of the 16th NZ time. From parts of Chile and Argentina, the moon will cover some 25% of the sun's disk, whilst from Antarctica around 49% will be covered. Orion is now high in the north after dark, with Sirius or Takarua, the brightest star in our nighttime sky, even higher. Below and to the right, and forming a triangle with Sirius and Betelgeuse, is Procyon, the brighter of the two main stars that form the constellation of Canis Minor, Orion's small hunting dog. Procyon is the 8th brightest star in the nighttime sky, and like Sirius, at 9 light-years distant, is one of our Sun's nearest neighbours at just 11 light-years away. Also like Sirius, it is in fact a binary system, with a 1.5 solar mass primary and a faint white dwarf companion. Just over a third of the way between Sirius and Procyon in the constellation of Monoceros is M50, a pretty heart-shaped open cluster of stars visible in binoculars. Around a third of the way from Betelgeuse to Procyon is NGC 2244, a rectangular cluster of stars that is embedded in a faint nebula called the Rosette. Whilst the cluster is visible in binoculars and small telescopes, the nebula is more of a challenge and is best seen in long-exposure photographs. Below Canis Minor sits another pair of stars, Castor and Pollux, marking the heads of Gemini, the twins. Pollux, the higher and brighter of the two stars, is the 17th brightest in our night sky. It is about 35 light-years away from us, whilst Castor is in fact a sextuple star system located 52 light-years from Earth. Nearby to Eta Geminorum, at the foot of the twin of Castor, is the open star cluster M35, covering an area almost the size of the full moon. Under good conditions it can be seen with the unaided eye as a hazy star, but binoculars or a wide-field telescope will reveal more detail and are the best ways to view this lovely cluster. Next to Gemini is the faint zodiac constellation of Cancer, the Crab. At the centre of Cancer is a lovely open cluster of stars known as M44, Praesepe, the Manger, or the Beehive. At magnitude 3.7, the cluster is visible to the naked eye as a hazy nebula, and has been known since ancient times. It was one of the first objects Galileo studied when he turned his telescope to the skies in 1609. Galileo was able to pick out around 40 stars, but today we know that Praesepe contains over 1,000 individual members, with a combined mass of between 500 and 600 times that of the Sun. As one of the closest open star clusters to our solar system, M44 is a great target for binoculars or small telescopes, which will easily reveal a number of individual stars within it. Higher, and to the east of Canis Major, is Puppis, representing the poop deck of the great ship Argo, which we explored last month. Inside Puppis are two lesser-known Messier objects, M46 and M47. Messier 46, also known as NGC 2437, is a rich open cluster at a distance of about 5,500 light-years away. It is estimated to contain around 500 stars, of which around 150 are of magnitude 10 to 13. Estimated to be only 300 million years old, this is a young cluster and a lovely sight in binoculars or a small telescope. Astronomer John Herschel described it in his general catalogue of nebulae and clusters of stars as remarkable cluster, very bright, very rich, very large, involving a planetary nebula. This planetary nebula, located near the cluster's northern edge, is NGC 2438. A planetary nebula is formed when a low or intermediate mass star comes to the end of its life, ejecting its outer layers into space as a glowing shell of ionized gas. Whilst NGC 2438 appears to lie within the cluster, it is probably just a chance line-of-sight effect, as the radial velocities are quite different. NGC 2438 is estimated to lie somewhat closer than M46, at around 2,900 light-years away. Located around 1 degree west is another open cluster, M47. The two fit easily within one binocular field of view, and are often referred to as sisters. Messier 47, or NGC 2422, has actually been discovered several times. The first was sometime before 1654 by Giovanni Battista Hodierna, and then independently by Charles Messier on February 19, 1771. William Herschel also independently rediscovered it on February 4, 1785, and it was included as GC 1594 in John Herschel's General Catalogue of Nebulae and Clusters of Stars, the precursor to Dreher's New General Catalogue in 1864. Due to a sign error by Messier, the cluster was considered a lost Messier object for many years, as no cluster could be found at the position of Messier's original coordinates. It wasn't until 1959 that Canadian astronomer T.F. Morris identified that the cluster was in fact NGC 2422 and realised Messier's mistake. M47 lies at a distance of around 1,600 light-years from Earth, with an estimated age of about 78 million years. It is described as a coarse, bright cluster containing around 50 stars, scattered over an area around the same size as the full moon in the sky. It is bright enough to be glimpsed with the naked eye under good observing conditions, but best viewed with binoculars or a small telescope. There are a couple of other excellent binocular targets in Puppis, including open cluster NGC 2477, a wonderful rich cluster of over 300 stars described by American astronomer Robert Burnham as probably the finest of the galactic clusters in Puppis, along with its neighbour NGC 2451, both located close to the second magnitude star Zeta Puppis. Also known as Neos, this blue supergiant is one of the hottest, most luminous stars visible to the naked eye. It has a bolometric or total luminosity of at least 500,000 times that of the Sun, but with most of its radiation emitted in the ultraviolet, it is visually around 10,000 times brighter. It is also one of the closest stars of its kind to our Sun, at a distance of around 1,080 light-years. Our evening skies are still bereft of bright planets. Jupiter is the first to rise at around 1 a.m. at the start of the month. Mars follows shortly afterwards, and the two are joined by Saturn around 3:30 a.m. You may spot Mercury briefly at the start of February, rising in the dawn twilight around an hour before the Sun, but it will soon disappear from view as it heads back towards the Sun and into the twilight. By month's end, Jupiter has moved into our evening skies, rising at 11 p.m, Mars around 12:30 a.m, and Saturn by 2 a.m, making a diagonal line down the eastern morning sky. After 8 years at Space Place at Carter Observatory and being involved in the Jodcast for almost as long, I'm moving on to a new role in February, and so sadly this will be my last Southern Skies section. It's been a great pleasure bringing you a little taster of our wonderful New Zealand stars over the past few years and some of the amazing stories within them. I wish you clear skies and all the very best from the future. So farewell from me, Claire Bretherton, and the team here at Space Place at Carter Observatory.